Today's topic is on bonding, structure and the properties of matter, part 1. This session includes number 1, states of matter, number 2, changing states, number 3, formation of ions, number 4, ionic bonding, number 5, naming ionic compounds and chemical formulas, and number 6, properties of ionic compounds. States of matter. There are 3 states of matter: solid, liquid and gas. To identify the state of a substance at a certain temperature depends on how strong the force of attraction is between the particles of the substance. The force of attraction depends on the material, temperature and pressure. The next part of this slide explains the physical properties of solids, liquids and gases. This is represented as the simple model. So let's start off with solids. There are strong forces of attraction between the particles, which holds them close together to form a very regular lattice arrangement. The particles don't move from their positions, so all the solids keep a definite shape. The particles vibrate around a fixed position. The hotter the solid gets, the more the particles vibrate. Liquids. There are weak forces of attraction between the particles. They are closely spaced but still in constant motion, therefore constantly colliding. Liquids have a definite volume. However, they don't keep a definite shape. The hotter the liquid gets, the faster the particles move. And finally, gases. There are very weak forces of attraction between the particles, which allows them to collide more frequently in all directions. The particles don't keep a definite shape or volume and are widely spaced. The hotter the gas gets, the faster the particles move. There are some limitations of the simple model. This includes the first one. In the model, there are no forces shown, so there is no way of knowing how strong the forces are. And number 2, all the particles are represented as solid spheres, but in reality, the particles aren't solid nor spherical. They are atoms, ions, or molecules. The next one is the particle theory. This explains how a particle changes from one state to another. So here, this cycle from 1 to 8 explains how a particle can change from a solid to a liquid, then to a gas, and then from a gas back to a liquid to a solid. So point 1. A solid is heated and its particles gain more energy. This makes the particles vibrate more, which weakens the force holding the solids together. Number 2. At a certain temperature, which is called the melting point, the particles have enough energy to break the bonds. At melting point, solids turn into liquids. This is called melting. Point 3. When the liquid is then heated, the particles gain more energy. This energy makes the particles move faster, which weakens and breaks the bonds holding the liquids together. Point 4. At a certain temperature, which is called the boiling point, the particles have enough energy to break bonds. At boiling point, the liquid then turns into gases. This is called boiling, also known as evaporating. Point 5. As the gas cools, the particles no longer have enough energy to overcome the force of attraction between the particles. This allows bonds to form between the gas particles. Point 6. At boiling point, many bonds form between the gas particles. This then turns gas into liquids, and this is called condensing. Point 7. When a liquid cools, the particles have less energy, so they move around less. Therefore, there's not enough energy to overcome the force of attraction between the liquid particles. And this leads to point 8. At melting point, many bonds form between particles. The liquid then turns into solid. This is called freezing. For melting, boiling or evaporating to take place, the energy must be transferred to a substance by heating. And for condensing or freezing to take place, the energy must be transferred from the substance to the surroundings. This is because the force of attraction between the particles gets stronger. The amount of energy required to change the state from a solid to a liquid and from a liquid to a gas depends on the strength of the forces. The stronger the forces between the particles, the higher the melting and boiling point. In an exam, you might be asked to predict the physical state of a substance. The state of a substance at a given temperature can be predicted if its melting and boiling points are known. The table summarizes this below. If the given temperature is below the melting point of the substance, then it's a solid. If the given temperature is in between the melting and boiling point, then it's a liquid. If the given temperature is above the boiling point, then it will be a gas. For example, the melting point of oxygen is minus 218 degrees Celsius, and the boiling point of oxygen is minus 183 degrees Celsius. So you could be asked to predict the state of an oxygen at a given temperature of minus 200 degrees Celsius. The answer is oxygen will be in a liquid state as minus 200 degrees Celsius is in between the melting and the boiling point of oxygen. As shown on the previous video, the state symbols are the abbreviations for these physical states of the substances. There are some substances that can change directly from a solid to a gas or from a gas to a solid without becoming a liquid in between. This is called sublimation. Examples of a sublime is solid carbon dioxide and iodine. Formation of ions from its atoms. Ions are charged particles. They are made when electrons are transferred. Atoms lose or gain electrons to make a full outer shell, which form ions. Ions can be formed from single atoms or group of atoms. Remember, metal atoms lose electrons from the outer shell to form positive ions. That's also known as cations. And non-metal atoms gain electrons into their outer shell to form negative ions, which are known as anions. The number of electrons lost or gained is the same as the charge on the ion. For example, if 2 electrons are lost, the charge will be 2+. If 3 electrons are gained, it will be 3-. The electrons in group 1, 2, 6 and 7 readily form ions. Elements in the same group have the same number of electrons on their outer shell, so they have to lose or gain the same number of electrons. Example, all elements in group 1 are metals, and they have 1 electron on their outer shell. This means when group 1 atoms form ions, they will have positive 1 charge. And again, all the elements in group 2 are metals, and they have 2 electrons on their outer shell, which means when they all form ions, they will have a positive 2 charge. The same rule applies to groups 6 and 7. The only difference is instead of a positive charge, it will be a negative charge. Additional points to note. The charge of atoms are always 0. The charge of ions are always written as to the power of. For example, looking at the magnesium ion, it's got a positive 2 charge and it's written as to the power of. The equations to the left, shown in blue writing, are known as ionic equations, and this expresses the loss or gain of electrons from a metal or a non-metal atom. Formation of ions can be demonstrated in 2 ways. Number 1, ionic equations, as written on the previous slide, and number 2, the electronic configuration diagrams, and this will be shown on the next slide. So here we're going to learn how to write ionic equations. So for example, if a question asks you to write the ionic equation to form a single oxygen ion from a single oxygen atom, the word single is very important as oxygen naturally exists as O2, but the question asks you to write an equation for a single oxygen atom. So let's look at the steps. Step 1. Write the chemical symbol of the atom on the reactant side and the chemical symbol of the ion it forms on the product side. Make sure to include the charges of the ion. Step 2. Balance the charges on either side. So looking at the equation above, the charge on the reactant side is 0, as the atoms have no charge, and the charge on the product side is 2-. To balance charges, we can only add electrons. So you can add 2 electrons on the reactant side, which will give you -2 charge on the reactant side, which will form a new equation, as shown below. This gives you an overall -2 charge on the reactant side as well as the product side, and it's formed a balanced ionic equation. electronic configuration diagrams is the second way to demonstrate the formation of ions. So an exam question could ask you to draw the electronic structure of oxygen ion formed from its oxygen atom. So firstly, start off with the electronic configuration diagram for an oxygen atom, which is shown on the left with 2 electrons on the inner shell and then 6 electrons on the outer shell. Then draw an arrow to show it's forming the oxide ion, and then draw the electronic configuration for an oxide ion, which is 2 electrons in the inner shell and then 8 electrons on its outer shell. So it's basically gained 2 electrons to make a full outer shell. This forms an oxide ion. Very important, the number of protons and neutrons do not change when it becomes an ion. Atoms bond together to form compounds. There are 3 types of chemical bonds we're going to learn. Number 1, ionic bonding, number 2, covalent bonding, and number 3, metallic bonding. This session will only cover ionic bonding. Ionic bonding. An ionic bond forms when a metal atom reacts with a non-metal atom. The metal loses electrons to form positively charged ions, and these electrons are then transferred to the non-metal to form negatively charged ions. These oppositely charged ions are strongly attracted to one another by electrostatic forces. Ionic bonding forms ionic compounds. An ionic compound is a giant structure of ions with a regular lattice structure. The next part looks at how to form these ionic compounds. The electron transfer during the formation of ionic compounds can be represented by a dot and cross diagram, as shown below. The first example is sodium chloride. The electrons of sodium is represented as dots and the electrons of chlorine is represented as crosses. When sodium reacts with chlorine, the outer electron from the sodium atom transfers to the outer shell of a chlorine atom. This means sodium loses an electron and the chlorine gains this electron, which forms sodium chloride. Example number 2 is magnesium oxide. The electrons of magnesium is represented as dots and the electrons of oxygen is represented as crosses. When magnesium reacts with oxygen, the 2 outer electrons from the magnesium atom transfers to the outer shell of an oxygen atom. This means magnesium loses 2 electrons and the oxygen gains these 2 electrons, which forms magnesium oxide. This example is very important because, as you can see on the previous slides, we had 1 atom of each element, whereas on this slide we've got 2 chlorine atoms. Let's see why. So when calcium reacts with chlorine, calcium atom loses 2 electrons from its outer shell and transfers to 2 chlorine atoms. This is because chlorine atoms have 7 electrons on its outer shell and can only gain 1 electron to make a full outer shell. Therefore, 2 chlorine atoms are required. Once the ionic bonding takes place, calcium ion has a charge of +2 and 2 chloride ions each have a charge of -1. This forms calcium chloride. Naming ionic compounds. When naming ionic compounds, the metal name comes first, followed by the non-metal name. The name for the metal ion remains the same name as the metal atom, but for the name of the non-metal ion, the ending changes. So for example, if it's a magnesium atom changing to an ion, it becomes a magnesium ion. If it's a calcium atom changing to an ion, it becomes a calcium ion. But with non-metal ions, though the ending changes, it's not always the same. For example, if the non-metal ion is monatomic, so it's a single atom like Cl-, then the ending would be "ide", so for example, chloride, bromide, fluoride. Whereas if the non-metal is polyatomic, so for example, if there's more than 1 atom, and one of the atom is oxygen, then the ending will be "ate", for example, sulfate ion or nitrate ion. An exception to this rule is OH-, which is called hydroxide ion. So putting all these informations together, let's look at some examples of naming ionic compounds. Sodium chloride. As you can see, the metal comes first, followed by the non-metal. Lithium sulfate. Magnesium carbonate. There are some commonly used ions in the syllabus which should be learnt. These include nitrate ion, sulfate ion, carbonate ion, hydroxide ion, and ammonium ion. These charges shown here are the overall charge for the whole ion. For example, for nitrate ion is a -1. This charge is not just for the oxygen, it's for the whole ion NO3. The next 2 points are for naming compounds formed from 2 nonmetals. So if both atoms are nonmetals and one of them is hydrogen, then the hydrogen comes first, for example, hydrogen chloride. For other combination of nonmetals, as a general rule, the element that has the lower group number comes first in the name. Example, carbon dioxide. Carbon is from group 4 and oxygen is from group 6. Therefore, carbon comes before oxygen. Now let's look at how to write chemical formulas for these ionic compounds. When you make ionic compounds, the overall charge of the compound should be 0. To find the formula of a compound, look at the charges and work out how many atoms of each ion you need to make the compound have an overall charge of 0. The number of atoms is written at the bottom of each ion. Let's look at the first example. So that's Na plus and Cl minus. In this case, sodium ion has a +1 charge and chloride ion has a -1 charge. So you need 1 sodium ion and 1 chloride ion to make the compound have an overall charge of 0. So the chemical formula is NaCl. It can't be Na2Cl because 2 sodium ions will give you a +2 charge and 1 chloride ion will give you a -1 charge. This makes the overall charge of a compound +1, which can't happen as the compound should have an overall charge of 0. The second example is calcium nitrate. In this case, calcium ion has +2 charge and nitrate ion has -1 charge. So to make this ionic compound, if we use 1 calcium ion, which is a +2 charge, and 1 nitrate ion, which is a -1 charge, the overall charge of the compound will be +1. So the chemical formula can't be CaNO3. You need 1 calcium ion, which is +2 charge, and you need 2 nitrate ions, which gives you a -2 charge, so the overall charge of the compound will be 0. So the chemical formula for calcium nitrate is Ca brackets NO3 close brackets 2. So from this example, you can see the number of atoms for NO3 goes at the bottom, and the brackets must be used to show that the 2 is for the whole nitrate ion, as the nitrate ion has more than one element. The next slide will show you a quicker way to work out the chemical formulas. So, the previous slide explained the reason why the chemical formulas are written like that, for your understanding. Here is a quicker way to work it out. This strategy will be very handy for your exam. Example, write the chemical formula of the ionic compound for when calcium reacts with chlorine. Step 1. Write out the charges of each ion. So for calcium ion is +2 and for chloride ion is -1. Step 2. Ignoring the signs, swap the charge number on the ion, which would then become the number of atoms for each ion. So the charge number 2 of the calcium ion goes at the bottom of the chloride ion, and the charge number 1 of the chloride ion goes at the bottom of the calcium ion. So the chemical formula is CaCl2. One point to remember when using this strategy: if the charge number on each ion is the same, write the chemical formula without those numbers. This is because the charges cancel each other out to give an overall charge of 0. So for example, if it's Mg2 plus SO4 2 minus, this can be written as MgSO4. If it's Na plus NO3 minus, then it can be written as NaNO3. Properties of ionic compounds. They all have a high melting and boiling point. This is because there are strong bonds between the ions and large amount of energy is required to break the bonds. And number 2, they conduct electricity only in molten state. So when ionic compounds are melted or dissolved in water, the ions are free to move, allowing to carry electric current, which conducts electricity. However, they can't conduct electricity when it's in a solid state because the ions are not free to move. That's the end of ionic bonding. Covalent and metallic bonding will be covered in part 2 next session.